Hi, Mitch from Accurate Sound here. As some of you may know, I run an online digital room correction service, design high-resolution headphone filter sets, and I'm the developer for DSP software HLHost and HLHost. HLHost is a plug-in host application, which is what we're going to use today. I've been asked many times, how do I add convolution to Spotify, or a loudness control to Roon, or how about spatial audio like crosstalk cancellation to any one of the apps listed here, which are simply examples. I thought the best way to do this is to make a presentation explaining how digital audio loopback works, and then show step-by-step walkthrough demos on how easy it is to add plugins to any audio app or system-wide audio on Windows and Mac. Once set up, everything can be run minimized. It's just set and forget, so you just press play on your music player. HLHost is also available for Linux and Raspberry Pi and can be set up for loopback much in the same way I show here on Windows and Mac, but that's for a future presentation. Here's what I'm going to cover for this presentation and demos. Of course, there are some prerequisites of installing some software before this can work. We have to install loopback drivers for both Windows and Mac, install the HLHost application that hosts the plugins, and then install, of course, one or more plugins that we're going to use for the demo. I'm going to show how to configure loopback for Windows, both from a diagram and a live demo, and going to use Roon as the example. How to configure loopback on Mac, both, again, a diagram and Roon demo. I'm going to talk a little bit about automatic sample rate switching. We're going to use Qobuz BlackHole HLHost and HLConvolver as a demo to show how that works. Of course, there are options. You don't necessarily have to install a virtual audio loopback driver. A lot of pro audio interfaces come with the capability of hardware loopback or onboard loopback in the device itself. And I'm going to show a demo of that both on Mac and Windows. And an addendum using REW to sweep the entire loopback signal path so that we can see that in the digital domain it's basically completely transparent. So let's look at those prerequisites in detail. Specifically on Windows, we want to install a new virtual audio routing application called VB Audio Matrix, which is donationware. VB Audio Matrix allows the use of WASAPI exclusive mode to communicate directly from the music app to the virtual audio driver. This has been lacking on Windows for some time, so this is the first time that we can actually communicate through a virtual audio driver in exclusive mode. Another interesting aspect of VB Audio is the concept of a master clock to prevent clock drift between any of the virtual audio devices and any real hardware devices that are hooked up, as we will see. I should point out, though, that WASAPI shared mode can still be used, and as the measurements show at the end of this presentation, the entire digital audio loopback signal path, including HLHost application and HLConvolver in the signal path, is completely transparent. On Mac, we want to use BlackHole as an easy virtual audio device to install, which is also donationware. Both VB Audio Matrix and BlackHole are multi-channel capable, so whether one is running a 7.1.4 Dolby Atmos system on a Mac, or a stereo triamp system on Windows, or 5.1 surround from Netflix, any type of multi-channel DSP processing is now available. HLHost is a simple host application that allows one to install as many plugins as you like and wire them up as you see fit. As we'll see, it's a very simple application. No command lines, no configuration files. It's dead easy to use. Next is to install some plugins. In this demo, I'm hooking up Terry's Crosstalk Shaper to Roon on Windows, a dynamic EQ loudness control to Roon on Mac, and convolution to Spotify. Because plugins are ubiquitous in audio music production, there are literally thousands of plugins on the market that can apply any type of DSP audio processing that you would like in your signal chain. So let's review a block diagram of the virtual audio loopback signal path. In this case, I'm using Roon as the application the music application. It could be any music application and or system-wide audio that is going to output into a virtual audio driver. Now that virtual audio driver is essentially the loopback mechanism, so that as anything that's fed into its input will be immediately available on its output. And so that means that a third-party application like HLHost can simply select the virtual audio driver output as input to the host application, run it through 1, 2, or more plugins, and then the output is simply going to out to the DAC. Very straight ahead, and once it's set up, just press play. Okay, so let's look at VB Audio Matrix. I've already downloaded, installed, and launched the application. This is the main window that you will see. While it looks daunting, for our purposes, it's very simple to use. Literally 4 or 5 mouse clicks and we're done. It shows all the available devices that you may want to initialize or enable. And in our case, we're simply going to enable these virtual audio input-output devices, 2 of them to be exact. And so the first step is to control-click on the online button to initialize or enable this virtual audio device with 8 channels of input and output. We will need a second virtual audio input-output device, and so we just simply control-click on VAIO2, and that becomes enabled. And while I could have Windows device output and other virtual ACO devices, etc., I've got a topping 2-channel DAC that I want to use, so I just simply right-click into ACO64A and open device selector and select my topping DAC. The last step is to right-click on the master clock button and select master. What this does is synchronizes, making sure that the clock is synced between the virtual audio devices and the hardware device by using an internal master clock. Very straight ahead to set up the devices, so let's go ahead and actually do that. Alright, here is VB Audio Matrix running on my Windows 11 computer. As mentioned in the slideshow, it's really straight ahead. On the virtual audio input-output devices, enable the first device with 8 channels of input and 8 channels of output. Enable the second device, and as I mentioned, I'm going to use a topping DAC, and I'm going to use its ACO driver. So right-clicking, open ACO device selector, select the topping USB device, and then I've already selected the internal clock, sync by internal device clock, and so I've made that device master. And that's it for configuring the devices. Let's look at how to actually configure the routing. Alright, let's have a look at VB Audio Matrix routing and HLHost audio settings. I wanted to put these 2 together because I wanted to show the complete signal path, so it kind of makes as much sense as possible. This is as hard as it gets as far as configuring VB Audio Matrix, but once you see how it works, it's pretty straight ahead. So all of the inputs are rows on the left, and all of the outputs are columns on the right. And as we've already discussed, we're using Roon as the example, and Roon's output is selecting the VB Audio Matrix virtual audio input-output device number 1. We're sending left and right channels in, and we can see on the output it's VB Audio Matrix, virtual device 1, channels 1 and 2. The way it works is you just simply control-click into the routing matrix to complete the signal path with no attenuation or amplification. It's just straight pass-through. So this is the loopback, which then is used as input into the audio settings of HLHost. And then the output, as we've already discussed, will now go into the input of VB Audio Matrix device 2. And so the virtual audio device 2. And what I've done here is, rather than just completing the loopback, we don't need loopback for this. We just simply take whatever's coming into the input and Control-click into the two spaces, and that is now going directly out to the left and right channels of the topping DAC that I've selected. So initially it looks a little daunting, but it's actually straight ahead and works quite well. So let's go ahead and configure that in Windows. Okay, so to get access to the routing matrix, all we have to do is simply click on Matrix, and out comes the actual routing grid. And so, as I've mentioned before, we've got the virtual audio input-output device 1, channels 1 and 2, and we want to make sure that they're going out channels 1 and 2 on the output. And so again, it's just simply Control-click, Control-click, and here we've established our loopback, so that whatever's coming in on the input is going on to the output. And then, as we've already configured the second virtual audio device, so there's the second virtual audio device, the input and output, and we can see that we've got the topping DAC channel 1 and channel 2 here, and so it's quite straight ahead. Again, just Control-click and Control-click, 0 and 0, 0 and 0, and so that is it. That is the extent of the routing matrix. And now let's have a look at HLHost Audio Settings Dialog. Okay, I've launched Hang Loose Host, and all we have to do is right-click and on either the input or output node and configure Audio I/O, or just simply double-click and we get the Audio Settings Dialog. Here I had ACO selected previously, so let's go ahead and select Windows Audio Exclusive Mode. And that should now change, and then here what we can do is select the VB matrix out 1. So the input is the VB matrix out 1 that we showed earlier. So what that means again is that anything going on the output of the virtual audio device 1 is being routed into the HLHost, and then the output is going to be the VB matrix output 2, or input 2 I should say, which is this right here. And so that now shows that we have this properly configured. We can change sample rates here, for example, to match what we've got going on with the rest of the input-output devices, but that's kind of another conversation which we'll have. And I should point out that if you're looking to do multi-channel, as you can see, we can kind of enable as many channels on that virtual audio channels, which we have 8 inputs and 8 outputs as one example. So that is the configuration now. If I return back to simply the stereo input and output, that's now the configuration complete for the Windows Audio Matrix and HLHost audio settings. Now let's go ahead and wire up some plugins. All right, here's a screenshot of what we're going to do. Now that we've already got the audio settings already selected, we're going to add a plugin to Hang Loose Host Canvas. We're going to configure the plugin, we're going to save the settings, and then we're going to go to the next step, which is getting Roon set up for using the plugin. But first, let's configure this in Windows. All right, now that we have the VB matrix configured, devices and routing is configured, and we've now selected the correct audio settings, having the correct virtual audio input and output devices, let's go ahead and add some plugins. So I've already installed some plugins on this computer, and there's a command here to edit the available list of plugins. And the way that HLHost picks up these plugins is that we scan for new or updated VST3 or LV2 plugins, And this is the common location where VST3 plugins are stored. Scan, and this list will grow if you have just installed a number of plugins. So in this case, for this demo, I'm going to right click on the canvas, and I'm going to select Terry's Crosstalk Shaper from Home Audio Fidelity, add that to the canvas. I'm going to open it up, and by double clicking on it or right click and show plugin GUI, either way will get you the user interface. And here I'm just going to increase this and give it an odd kind of setup so that we can just hear that the plugin is working. Of course, you would follow Terry's instructions on setting this up properly for your system, but this is just a demonstration to show that the audio is passing through the plugin through the circuit. Once you've got dropped one or more plugins, you can now wire them up by simply just clicking on the pins and dragging inputs to outputs, and that's it. It's as simple as that. And we want to save the filter graph so that when we launch it this next time, it will be exactly the same with the same settings that were just saved, that we just put together. And so now the next step is to hook up Roon to the virtual audio input device here, and that will be our next step. All right, so let's configure Roon. It's quite straight ahead. Just go into the setup, audio, and you'll see a number of entries like VB Audio Matrix, VAIO. There'll be several in a row, and they don't necessarily have their numbers identified, but I found that the very first one that you see in the matrix, or you see in the audio devices, I should say in Roon, that is usually VAIO1, and so just simply click enable that, and then I just gave it the name so I could recognize it, and then click on the cog icon and select device setup. So in device setup, what I've done is that I've turned on exclusive mode, and pretty much left everything else exactly the same. So let's go ahead and configure that in Windows, and let's listen to some music. All right, I've launched Roon, and now we're going to configure the audio by going to the audio settings and configure the device. And so, as I mentioned before, the VB Matrix, Audio Matrix virtual audio input-output devices, you can see they're not numbered here in Roon. However, the very first one in the list should be the first virtual audio device. So go ahead and enable that. And then I've given it the name as VAIO1, and then click on Device Setup. And I've just got all of the defaults, so I have low defaults. The only thing I've changed here is I have turned exclusive mode on and saved that. And then the next step is to go ahead and select, if you haven't already, select the VAIO1 as the output device. And what I'm going to do is play some music here. And we're going to check that the meters are, input-output meters are working, and that the hang loose host is getting input metering. And then I'm going to open up Crosstalk Shaper, and then click on bypass, toggle between bypass and processing, so that you can hear that the audio is actually being processed through the plugin. As I mentioned before, these are odd settings just to demonstrate that the plugin's actually working and that the audio is passing through it. Of course, you would read the manual in order to set it up properly. Okay, with that in mind, let's go ahead and play some music. right, so as we saw, there was input-output. We were getting a lossless signal, which is a first for a virtual audio device on Windows. And as we can see on the audio input, we were getting input. And when we were toggling back and forth between the effect being on and off, you should have heard a clear difference with the effect. It's definitely in the sound stage and some tonality that's being changed. And again, just to be clear, this was just to demonstrate that there's signal passing through the plugin. And of course, if you were using this plugin, you'd follow Terry's instructions to set it up properly. So with that in mind, let's look at some options about this setup. I just wanted to mention a couple of options. So once you have everything configured and saved, you can then set HLHost and VB Audio Matrix to run at OS startup and in minimized mode. So basically set and forget. And then the only thing you have to do is press play. I wanted to also mention that this works for multi-channel setups, whether it's a surround setup of some sort, 5.1, 7.1, or stereo triamp or biamp setups or biamps with subs, etc. Those all work because VB Audio Matrix is a fully multi-channel virtual audio driver and can take care of those setups. I also wanted to make mention of Windows WASAPI shared mode, and that's for browser-based audio or applications that can't select Windows exclusive mode. So in shared mode, they're able to get access to the virtual audio driver loopback that we've just configured. In fact, no changes are required, which I'll demonstrate here. So in shared mode, the only thing that you have to do is select from Windows Audio speaker icon is to select the VB matrix in 1, the VAIO1 that we've configured, and turn the volume up to 100%, and that's it. So anything that is running Windows Audio based will now be put through VB Audio Matrix and into whatever plugins you have loaded. No changes are required whatsoever for VB Audio Matrix. The only thing is, it's just like in Roon where we're selecting the VAIO1 output. In Windows Audio, you are also selecting the VAIO1 audio output. And so this allows for applications like Spotify, which I have running here on the Windows computer, and that audio is now going directly into the loopback mechanism. And in this case, I've got Hang Loose Convolver is the plugin where I can use either digital room correction for Spotify or any browser-based app, and whether I'm using room correction or headphone filters is another application for this kind of configuration. All right, and so that brings us to the conclusion of the Windows audio configuration. Let's move on to the Mac. All right, let's get started on the Mac. Unlike Windows, where there's a half dozen or so audio protocols, the Mac only has one protocol, the Core Audio. And so it's really simple to set up. I've already installed BlackHole, and so all we need to do is go to Audio MIDI Setup and then select BlackHole as the device, and then right-click and select Use this device for sound output. And then looking at the Output tab, we just want to check to make sure that the volume is set at 1.0 or basically 100% or pass-through. And so this is the extent of the configuration of BlackHole on the Mac. Of course, there is other virtual drivers with more channels, but it's exactly the same process. So let's go do it on the computer. All right, configuring BlackHole on the Mac couldn't be any easier, so open Audio MIDI Setup, and here I've selected BlackHole as the device. Right-click, use this device for sound output, And then we want to just check the output tab to make sure that the volume is at 1.0 or 100% or basically pass through. And as mentioned before, of course, there's other audio drivers, virtual audio drivers that have more channels that can be configured in exactly the same way. Okay, so now that we're done, let's go and configure HLHost audio settings and some plugins. So for the Mac demo, I thought I would do something a little bit different and introduce a very cool plugin that's free, and it's basically what's called a parallel dynamic equalizer. And so what that means is that it's not only an equalizer, but it has compression, expansion settings that you can use to alter the dynamics of the music. And so why would we want to do that? Well, I find that most music players don't have a loudness control, and so that's what we can use this particular plugin for, is a dynamic loudness control. And the reason for that is that I have my system calibrated at around 77 to 83 dBSPL using digital room correction. Everything sounds balanced as it should, but when I turn the volume down, our ear sensitivity goes down on the frequency extremes. So the bass, all of a sudden our ears aren't as sensitive to the bass, and it seems to really drop off quickly. Same with the treble. So at low listening levels, which I want to listen to when I'm working on the computer or puttering around the house, but I still want the full sound. I've got a couple of subs and I would like to hear those subs. So here's a good way of doing that. And so not only can we use the equalizer to boost the low and high frequencies, but we can also put on a compressor, which with a soft ratio in music production speak is a 2-to-1 ratio. And so that just compresses it enough, as we'll see, to give it kind of a punchy sound. So not only can I get the low frequencies back at low listening levels, but I can get a nice punchy sound that goes with it. Perfect for background listening. Why I don't understand music players, the vast majority of them don't have a loudness control, is certainly beyond me. No idea why that is, and so here's a way to incorporate one in your system. Now, as far as the BlackHole settings are concerned, it's dead easy, right? So we've already selected BlackHole now as the input. So the output of BlackHole, whatever's feeding it, is going to be input into Hang Loose Host. And I've selected just a 2-channel topping DAC on the output, and that's it. It couldn't be any easier. So let's go ahead and set that up on the computer. All right, I've got HLHost up and running, and so the first thing to do is to go under the Options menu and select the Edit the List of Available Plugins. And the reason why we're doing that is we want to make sure that we've picked up all the plugins that are installed on the computer. So under Options, simply select Scan for new or updated audio units, VST3 and LV2 plugins. And once you've done that, just simply close, and now when you right-click on the canvas, all of those plugins are now available to you. So in this case, we're going to select Tokyo Dawn Labs, the TDR Nova, the equalizer, parallel dynamic equalizer that we were talking about. Now we can just select the audio settings, and you can either right-click on the input or output nodes and go Configure Audio I/O, or you can just simply double-click and up comes the audio settings dialog. Here we just select BlackHole as the input, and that was the loopback that we get. So Roon is now going to select the BlackHole driver, and we're going to get its input here into HLHost. And then the output is a topping E30 DAC that I have connected. All right, so now we can just wire it up and have the input going into the input of the TDR Nova plugin, and the output going to the output to the topping E30 DAC. And that's it, we're ready to go. Okay, so let's set up Roon for output to BlackHole. Just like on Windows, on Mac, we're going to do the same thing from this Roon setup. Select audio, select the BlackHole device, enable it, give it a name, and then click on the cog icon and select device setup. In device setup, I've just simply left the default values. Note that exclusive mode is off. I'm going to come back to this in a while and we'll talk about that. But first, just simply hit save and we're ready to go. So let's do it on the computer and listen to some music. All right, so I've got Roon open in audio settings, and here I'm looking for the BlackHole driver. I've obviously already selected it and gave it a name. And then, as mentioned before, we want to look at device setup. And like I say, the defaults are loaded. Save that. And we're now ready to go. I've selected BlackHole as the output. And so the next step is to configure TDR Nova. As you can see, I've got a little bit of a configuration here that I've already preloaded and saved as a loudness.filter graph. And the reason why I've just played around with the settings a little bit, and we're talking about loudness, and so I'm going to play some music and then I'm going to bypass it in and out, and so you can kind of hear the effect that's going on. It's a little bit exaggerated, and I wanted to do that on purpose so that you can clearly hear the difference between bypass and with the dynamic equalizer working. So let's give that a listen. All right, so you should have heard the effect of the dynamic equalizer coming in and being bypassed. And so there we have it, very straight ahead setup to get Roon to work with a plugin. And coming back to that subject about, I was showing there that it's a high quality audio, that we're still going through the Mac audio mixer. And, we'll have a few words about that later, but suffice to say that I've taken REW measurements, which I'll show later, in this exact path through the Mac OS mixer, and as we will see, it's perfectly transparent. So the next step is to look at automatic sample rate switching. Just before we get to automatic sample rate switching, I just wanted to mention, just like on Windows, on Mac, HLHost can be set up to run at startup and run minimized. So once you have everything all configured up the way that you want to, it's just set and forget. All you need to do is start the computer and press play, and all your DSP processing will work. With respect to BlackHole, it can be set for up to 256 channels of digital input and output, so it should handle any multi-channel scenario that one can throw at it. With respect to automatic sample rate switching, Qobuz to BlackHole does properly notify BlackHole of the sample rate change, and everything is propagated down the chain. Other apps, not so much. So for those apps, it's just simply easier to use a resampler set at a fixed rate like 48 kilohertz or 96 kilohertz, a sample rate, for example, and kind of what me worry. So let's have a look at how Qobuz does it. All right, let's talk a little bit about automatic sample rate switching. In this case, I'm on the Mac and I have BlackHole set up. I have Qobuz in the background playing some music. I have Hang Loose Convolver as a convolution plugin plugged into the HLHost. And here, I just wanted to demonstrate that I was playing a tune at 44.1 kilohertz and it switched to 192 kilohertz. That is propagated into BlackHole, so 192 kilohertz sample rate, and then same in HLHost, which I haven't shown here, but I just wanted to show in that in HLConvolver, if there's a filter for 192 kilohertz, then that filter will automatically be loaded. So the automatic sample rate switching does work in Qobuz. It may work in other applications, but it is possible. And so one thing I wanted to point out here, and there is a link to it in the slides that I've included for this presentation, is that I'm talking to the BlackHole developer. There is a little chunk of code that application music app developers can put into their apps that will facilitate the change of automatic sample rate switching. Again, though, however, it requires the music app developers to actually code for that. Not too many do, as it turns out, but in the case of Qobuz, it's certainly doable. As I mentioned previously, if the automatic sample rate switching doesn't work, then just simply pick a sample rate that you're happy with, 48 kilohertz or 96 kilohertz, and let the resampler do its work. And again, most are very transparent, and what me worry, enjoy the music. Okay, in addition to virtual audio device drivers, loopback drivers, there is a couple of other options available. One of them is using hardware loopback in the actual device itself. So pro audio interfaces, typically multi-channel pro audio interfaces, have the capability to provide loopback on board the device itself, so no virtual audio drivers required. In this case, I've got the Mo2 Ultralight MK5 multi-channel DAC hooked up to my system, and the way it works is that I have Spotify running in the background playing music. It's going out to line out 9 and 10, channels 9 and 10 on the Ultralight, and if we look over here we can see that that source is used for loopback, and then it's loopback as inputs, loopback in 1 and 2 for the Ultralight. And so now that is coming into Hang Loose Host, going through Hang Loose Convolver for digital room correction, and then through Xtalk Shaper for crosstalk cancellation. So it's relatively easy to set up. As you can see here in the audio settings, I've just simply selected the ACO device, Mo2, and then I don't show it here, ran out of space, but line out 9 and 10 are also enabled, and that provides the output to the loopback input of 1 and 2 through the processing, and then out main out 1 and 2. So it's just another approach to provide loopback for getting audio into Hang Loose Host, whether it's app specific or system-wide audio. We can also do the same thing on Mac. Let's have a look at that. All right, hardware loopback on the Mac is very similar to Windows. There's only one small difference. So let's walk through it again. So I'm using Spotify, and rather than being able to specify on the Mac the channels 9 and 10 like I was able to do on Windows, it just simply defaults to going out on channels 1 and 2. So here in the Mo2 QMix application, I'm able to select USB out main 1 and 2 as the loopback source, and then of course it comes back in on loopback 1 and 2, and therefore it's going to go through the Hang Loose Host application. In this case I've got Hang Loose Convolver as the plugin, and then the output in this case I've got going to channels out 3 and 4. I've got headphones plugged in and listening to Spotify in the background. Again, hardware loopback, it does not require a virtual audio loopback driver. It's simply the capability that comes with most pro audio multi-channel DACs. Okay, technically that's the end of the presentation on the virtual audio loopback drivers, how to install them on both Mac and Windows. I also provided a couple of options there for hardware loopback on Windows and Mac. And this little section here, I wanted to provide some assurance that the audio passing through both the Windows Audio Mixer and Core Audio on the Mac, along with the loopback drivers and the HLHost plugin application and any of the plugins, I just wanted to show that it is indeed transparent. There is no distortion being added, and there is no alteration of the frequency response or phase response. So here what I've done is I've got REW loaded up, and I've used the virtual loopback drivers in the audio matrix, including VAO to output, and I'm passing it through Hang Loose Host with Hang Loose Convolver as a plugin, and I've loaded in a Dirac pulse as a filter. And so a Dirac pulse is one sample with a value of 1, and it's basically a do-nothing filter, but I wanted to show the whole path through convolution, through Hang Loose Host, and through the audio drivers. And if we look at the result, we can see that I've swept the frequency response from 5 Hz to 24 kHz at a 48 kHz sample rate. And as we can see, perfectly flat frequency response and perfectly flat phase response. And so there is no alteration of the frequency or phase going through this signal path. So I've put in that REW output. I was using the Java driver, by the way, into VAO output input 1. The output goes into the host. Through the convolver, the host output goes into another virtual audio loopback device, and then back into the REW input. Much the same way on Mac Core Audio, I did exactly the same thing. I did put the convolver in the signal path along with the BlackHole virtual audio driver. And again, as we can see, perfectly flat frequency response, perfectly flat phase response. And I used a second virtual audio driver, loopback driver called ground control. So that allowed me to take the REW output, put it through BlackHole into HLHost through the convolution, output into ground control virtual loopback driver, and then the output of that is back into the REW input. And finally, looking at 24-bit in and out audio loopback with the plugin, I just wanted to make sure folks understood that the theoretical limit is basically for 24-bit audio is minus 144 dBFS. And so here we can see we're very close to the theoretical limit by looking at the distortion. So basically with minus 140 dBFS distortion readings, the signal path is indeed completely transparent. Okay, that wraps up the easy way to add DSP plugins to any music app. I hope you found it useful. If you have any questions, please leave a comment or reach out directly at my website. Enjoy the music.